So let's quickly recap the lens makers, before which we have to deal with a convex spherical refracting surface. The question will be about a convex spherical refracting surface where the object is in the rarer medium and the image is in the denser medium. So you have to draw object as O, mark object as O. I have to draw a normal here at the point of incidence, and this will be a center of curvature, and this is the point A. The ray of light will get bent towards the normal, and this is where your image would be. And the angle the incident ray makes with the normal is I. The angle that the refracted ray makes with the normal is R. Let's mark the object making an angle as alpha, image making an angle is beta, the gamma is the angle the center of curvature makes. Let's draw a normal AN, which is so close to the pole that you can make all measurements from N. And here the light ray is entering from rarer to denser. So rarer to denser is mu of, okay, first of all let's identify the exterior angle. I is an exterior angle of the triangle alpha plus gamma. Can you see I is an exterior angle of this triangle, which is alpha plus gamma. And gamma is an exterior angle of this triangle. Gamma is equal to R plus beta. So R is equal to gamma minus beta. You can write this as tan alpha plus tan gamma. This is tan gamma minus tan beta. Tan alpha from this triangle is opposite, which is AN by ON. Tan alpha is AN by ON. Tan gamma is AN by NC. And tan gamma here is again AN by NC minus tan beta is AN by NI. So thus you got your I and R. Here the light ray is entering from rarer to denser. So mu of 2 with respect to 1, which is mu 2 by mu 1 is equal to sin I by sin R, which can be written as I and R. So mu of 2 R is equal to mu of mu 1 into I. Mu of 2 into R from here is AN by NC minus AN by NI is equal to mu 1 into I, which is AN by ON plus AN by NC. AN throughout get cancelled using sign conventions. 1 by NC is the radius of curvature, which is R to the right side, so 1 by R minus 1 by NI. NI is the image distance, which is B to the right side, so like this. So mu 1 into 1 by ON. ON is to the left, so object distance, which is minus U, plus 1 by NC, which is again to the right, so radius of curvature is 1 by R. Bringing it inside is mu 2 by R minus mu 2 by V is equal to minus mu 1 by U plus mu 1 by R. Now consolidating, you need mu 2 minus mu 1 by R, so you can take it that side. So write 1 by R into mu 2 minus mu 1 is equal to, this goes that side, a mu 2 by V minus mu 1 by U. This is the first conclusion. Question is, the object is in the rarer medium and image is in the denser medium for a convex spherical refracting surface. This shows that's a real image. The fact that it's undergone refraction shows that the image is real. So the question may be the object, they may ask for a real image. So anything might be a question, but you should know this is the answer. So the next is for a concave spherical refracting surface. This is a concave spherical where the object is in the denser medium. So the light ray from the object will come from here to here. This is the point of incidence. You need to draw a normal at the point of incidence, joining the center of curvature C. And the light ray here is going to bend away from the normal. So it's going to go away from the normal. You're going to get a virtual image. So the question is about virtual image, means this is a diagram where the object and the image are on the denser medium. So depending on the question, so this is alpha, this is beta, and this will be gamma, and this will be normal, and this is the pole. And we have to mark the angle of incidence, the incident ray making with I, the refracted ray making with the normal is R. And can you see from this triangle, the entire triangle, I is an exterior angle, so I is equal to gamma plus alpha. R is an exterior angle of this extended ray here, and so then this triangle, so R is equal to gamma plus beta. Tan gamma plus tan alpha, this will be tan gamma plus tan beta. Tan gamma is AN by NC plus tan alpha is AN by NO is equal to, here what is tan gamma? Tan gamma is AN by NC plus tan beta is AN by NI. Here light ray is entering from denser to rarer. So it's mu of mu 1 by mu 2, not mu 2 by mu 1. Mu 1 by mu 2 is equal to I by R. So mu 1 into R is equal to mu 2 into I, which is mu 1 into what is R? From here it's An by Nc plus An by Ni is equal to mu 2 into I, which is An by Nc plus An by No. An by No. An throughout gets cancelled. Using sign convention, what is Nc? Radius of curvature, which is minus 1 by R, plus what is Ni? Ni is the image distance which is on the right side, which is 1 by V, is equal to mu 2 into what is 1 by Nc, radius of curvature, which is left, so minus 1 by R, plus 1 by No is the object distance which is right, so 1 by U. So taking it inside, minus mu 1 by R plus mu 1 by V is equal to minus mu 2 by R plus mu 2 by U. You want to get mu 2 minus mu 1 by R, so take it to that side. So you get 1 by R into mu 2 minus mu 1 is equal to, bring this that side, mu 2 by U minus mu 1 by V. So this is the final formula for the second one. Okay, so the next is about lens makers. They ask you about lens makers. It's a combination of these two, because you have this surface in which the formula was mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R, and this surface, okay, which was mu 2 by U minus mu 1 by V, which is mu 2 minus mu 1 by R. You're going to change it around because you're going to use the combination of this. So this is where your object was. This goes and forms an A here. It's going to dotted line going to form a first image here, and then it's going to form a final image I here. This is all the diagram you need to do. And you know that this curvature will have an R1, this curvature will have an R2, so then let's mark it as R1, mark it as R2. The image, first image that you got here is not V, it's V dash, so it's V dash, and the object here is also V dash. So if you change this around as 1 and 2, and write the explanation that this is for a convex spherical refracting surface and this is for a concave spherical refracting surface, and then solve it, you get a mu 2 by V dash. Mu 2 by V dash can be cancelled, so this is minus, this is plus, and this is with a minus. So you get a mu 1 by V minus mu 1 by U is equal to mu 2 minus mu 1 is common, 1 by R1 minus 1 by R2. From here you can take the mu 1 out, 1 by V minus 1 by U is equal to mu 2 minus mu 1 into 1 by R1 minus 1 by R2. You can bring the mu 1 to denominator here. Write this as 1 by F, because by lens formula 1 by F is equal to 1 by V minus 1 by U. Split this up, mu 2 by mu 1 minus 1 into 1 by R1 minus 1 by R2. So 1 by F itself is therefore mu of 2 with respect to 1 minus 1 into 1 by R1 minus 1 by R2. Thus the lens maker's formula, in general they'll say mu minus 1, which is understood that's 2 with respect to 1, which is 1 by R1 minus 1 by R2. This is how lens makers is. There may be other questions that can also come when it comes to what we dealt with in the first place is the object is in the denser medium, and rarer medium, image is in the denser medium. What if the question is object is in the rarer and image is also in the rarer? So what if they change the question like that? So then that's the next part, where the object is rarer and image also in rarer, shows that it's going to be a virtual image. Okay, so then in that case you're going to draw the lens like this, the convex spherical refracting surface. But in order to get the image to be rarer, you have to draw the object closer. When you draw the object closer, this is where your point of incidence is. You're going to join it with the center of curvature. This right ray will form it's going from rarer to denser medium, so it's going to bend towards the normal. So when it's going to bend, instead of going straight like this, it's going to go a little bent like this, and so it's going to appear to come from a point I, and thus you can get an image here. So this is the diagram you should know. This is alpha and this is beta, and this is the normal, and this is your center of curvature, which is going to make an angle gamma. So with this again you can prove the same thing. Here the light ray is entering from rarer to denser, so it's mu 2 by mu 1 is equal to I by R, and the rest of it can follow as it is, but you should identify where is I, what is R. Where is the incident ray here? The object making an angle with a normal is the incident ray, which is this whole angle is incident ray, correct? Angle of incidence. The refracted ray is here. and that is going to make an angle is here, which is R. So this identifying I and R is important. Can you see I is an exterior angle of this entire triangle? Can you see? Therefore I itself is no, not the entire triangle, I'm sorry. I is an exterior angle of this triangle. I is equal to alpha plus gamma, and R, which is here, is an exterior angle of the entire triangle. Yes, R is an exterior angle of the entire triangle. So R is equal to beta plus gamma. So you should identify like this: R is equal to beta plus gamma, I is equal to alpha plus gamma, and rest of it is the same. You know, you can write it as tan alpha plus tan gamma and tan beta plus tan gamma, and proceed the same way as it is. Only the diagram is the crux. The rest of it is something you can do it by yourself. Here again, it's object and image. It's a convex spherical refracting surface. The object is in the rarer and image is also in the rarer. When it comes to object in the rarer, the same formula will follow. It's mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Just when object is in the rarer, whether even though image was in the denser, you still get the same formula as the final formula here. Just you have to remember this, okay? That is the crux. If you know this, you can write this. The next thing that they can ask is object lies in the denser medium. Object itself is lying in the denser medium. Image formed is real. Means this can be a denser medium. The object is here and the image is also going to be in the same side. So you have this to be the incident ray. They will never ask this. Whatever I taught you is what is important. They've never ever asked any of the other conditions. But in case they ask, we should know. That is the only reason why we are doing it. Okay. So then this is the point of incidence A with the normal. The normal will be with the center of curvature here, right? This will be the normal, and this is the incident ray making an angle with the normal. This whole thing will be an eye in that case, correct? Or in other words, this can also be an eye. Okay, that side or this side. Okay, so yeah, but you have to get a image on the same side. So this is from denser, it's entering into rarer. It's going to bend away from the normal. No, it's going to bend. Yeah, it's going to bend away from the normal. How do I do this? If it's going to bend away from the normal, it's going to come like this, which means your image is going to be further away. 1 second, hold on. Where is the image? Oh, this is no, this condition is for the image to be on the rarer side. So then, you know, it's going to come here. The image is going to bend away from the normal. Obviously, you'll get an image here. So this is your alpha, this is your beta, and this is your gamma, and this is your an, and you can proceed. Since here the object is in the denser, the second condition will follow, which is mu2 by u minus mu1 by v is equal to mu2 minus mu1 by r. The same condition will follow. Where the objects was in the denser was the second condition that we learned. The same thing that you have to write. That will be the final formula. You have to derive it. Okay, again, here if you see, which is r is the refracted ray making with a normal. And I is an angle. Can you see gamma is an exterior angle of this triangle? Alpha is an exterior angle of this triangle. What is this? This angle is gamma. Gamma is an exterior angle of alpha plus I. And R is an exterior angle for which triangle? Alpha plus beta.
Gamma plus beta.
Gamma, okay, I'm confusing myself. R is a gamma plus beta. With the same thing that you use, you can find what is I from here, what is R from here, and substitute it, and then you will arrive at this formula. But never have they ever asked all this. I'm just telling you additional points, that's all, okay. So let's go to next. Some numericals I'll do based on all this, okay. So light from a point source falls on a convex spherical refracting surface. Convex spherical refracting. When I know convex spherical refracting surface, light is falling, I know the formula has to be mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Now you know, without learning that, how do I teach you all this? I will say, you will all shake your head, but you won't know. When I'm getting angry, I won't get angry like that சும்மாலாம். இது தெரியாம நான் எப்படி இதெல்லாம் எடுக்க முடியும்? So then light from a point source falls on a convex spherical refracting surface of refractive index 1.5. The radius of curvature R itself is 20 centimeter. The distance of the light from the glass is, this object is 100 centimeter. Okay, and at what position will the image be formed? V is all you want. Okay, you know mu2 has been given 1.5. Obviously this will be air, and the refractive index of air you can take it as 1. Okay, refractive index of water is 1.33, refractive index of glass is 1.5, refractive index of air is 1. அப்படிலாம் போடுவாங்க. அப்போ நம்மளே போட்டு பார்க்கலாம். It's 1.5 by, I don't know, V. Minus mu1, I'll take it as 1 because the refractive index of air is 1. By U is been given as 100 centimeter. Now it has to be substituted as minus 100 because it is to the left. I have arrived this formula using sign convention. I arrived this formula using sign convention. But during numericals, I should again put the sign convention. That's something you should not forget. Okay. So this will become minus 100 is equal to mu2 minus mu1, which is 1.5 minus 1 by r, which has been given to be 20. Can the radius be taken as positive? Yes, because it is on the right side. So because I need to check on the sign convention. So 1 by 5 plus by v plus 1 by 100 is equal to 0.5 by 20. So 1 by 5 by v is equal to 0.5 by 20 minus 1 by 100. Can we write this as 5 by 200? My 1 by 100, multiplying both sides by 100. So 1.5 by v. So LCM will be 200. It's 5 minus 2, which will be 3 by 200 is equal to 1.5 by v. Correct? And you all know 15 2s are 1.5 into 2 is 3. So then therefore 2v is equal to 200. So v is equal to 100, and I got a positive answer, v centimeter. Are you clear? You have to still fill in the sign convention is the most important thing. This is an SEBSE question. So next, go to next question. So did I read the question? I'm just reading out the question for you. It's example 36 in Aurora, where the light from a point source in air falls on a convex spherical refractive index 1.5. Radius of curvature 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. At what position is the image formed? That was this question. So can I go to next question? The next question, I'll just choose this. Example 38. Only the important sums I'm doing. For according to me, if you do this, it is minimum. It is enough for you to pass or get 80% or whatever. Okay, but you should be doing it thoroughly well. Okay, the diameter of the glass sphere. Okay, here they've given glass sphere. Diameter of the glass sphere is 15 centimeter. A beam of light strikes the sphere, which converges at a point 30 centimeter behind the pole of spherical surface. Find the position of the image. Okay. When they give you a sum like this, you should please understand a beam of light strikes the sphere, which converges at a point 30 centimeter behind the pole of the spherical surface. Means a beam of light is converging like this, such a way that it's converging at a point 30 centimeter, so that it will be 30 centimeter behind this pole. What to say? The understanding of the question is what is very critical in this sum. Again, I'm telling you, a beam of light strikes the sphere. You can't first itself you can't. Okay, I'm drawing it in such a way that it's striking. It is striking, not parallel to the axis. It is striking like that, so that it converges at a point straight away. It converges, which means you are not using the sphere at all. It strikes it, and if there was no sphere, it would have converged at a point 30 centimeter behind the pole. This is the pole. Whichever where the point of incidence is happening, that surface becomes the pole. So this is the pole. So this whole distance is 30. Okay. Now for this spherical surface, this will serve as an object. For the first surface, what is happening? This is going and converging there. For the second surface, it's going to serve as an object. In the absence of the glass sphere, the light ray will, okay, imagine that there's no glass sphere at all. The light ray would converge at a point, let's call it as O, in the absence of the sphere. Now that there is a sphere, this O will serve as an image. Correct? O will serve as an image. Now what is going to happen is, now that there is suddenly the sphere has come into account. Now that the sphere has suddenly come into account, this becomes your pole. And this is going to converge this. At some point this is going to converge it. I don't know where it's going to converge it or anything like that, I don't know, correct? So it's going to converge it. What I can say is, for this spherical surface, for this purple color spherical refracting surface, u is plus 30 to the right side of it. For this spherical refracting surface, which is the first surface, u is 30. Okay, you know u is 30, and you know the diameter has been given, so you know the center of curvature, the normal will pass through center of curvature, right? And so then that normal is passing through the center of curvature. Yeah, it will be like this, and that will be the radius of curvature, which will be 15 by 2. So I know the radius of curvature is 15 by 2. I know object distance is 30. This is like a light ray entering from, okay, let's say this is like a light ray entering from ray into the denser convex spherical refracting surface, which was the first case. Yeah, which was mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. So you know mu2 is the glass, which is 1.5 by v. You don't know what is v. By mu1 it is 1, because what is striking is air, correct? By the v is 30, u is 30, is equal to mu2 minus mu1 is 0.5. By r itself, you know, is 15 by 2, 7.5, which is 7.5. So thus you have to write this statement. It's a very, very complicated sum, in the sense to understand that the question, when the two rays, okay, when the beam of light strikes a sphere, it converges at a point 30 centimeter behind the pole of the spherical, means you should consider that there is no sphere, and you should consider that this is 30, so that from this pole it is 30. Now this pole is going to come into play, and it's going to converge it somewhere at a point further, whose distance I don't know. I know u itself is 30. That's what makes this sum very, very special. Are you clear? Isn't it difficult to understand the question?
Yes,
It is. So if you know this very well, only you can do this sum. I'm making it very clear. You must thorough this sum. So now let's do this sum. Now everything else become very easy. Only the understanding of the question is difficult. So 1 by 5 by v minus 1 by 30 is equal to 5 by 75. Yeah? 5 ones are 5, 5 5s are 25. So 1 by 5 by v is equal to 1 by 15 plus 1 by 30. So 1.5 by v is equal to 30 is LCM, 2 plus 1 is 3. This will become 10, and cross multiplying v will become 15. So you understand, where will 15 be? If this is 30 exactly here, therefore you know that this is going to converge at this point. Otherwise you won't know. He is straight away in Aurora, he would have drawn it. But how the hell you know that it's going to converge here? Unless you calculate your v, you won't know. Then only you can complete your diagram. So this phase, this circular face is actually converging it at this point, and you're getting a final image here. So that's this question, very important, okay? So then next is next important question is, okay, let's do this. Example 40. Okay, a mark placed on the surface of a glass sphere. See, these questions have never come. This question has come. Similarly, these questions have come, whatever I've dealt with, but this question has never come. But I always teach it on the your school exams will have these questions, but not the board exam. But let's learn it. A mark is placed on the surface of the glass sphere and is viewed through a glass from an opposite direction. ஒரு ஸ்பியர் எடுத்துக்கோ, அதில் ஒரு மார்க் போடு, அதை இங்கே வச்சுடு, அந்த சைட்லேருந்து யூ வியூவிங் தட் மார்க். ஓகே, ஸோ ஆக்சுவலி திஸ் இஸ் த ஸ்பியர். Okay, this is the mark. See, I'm marking it here. Mark placed on the surface of glass sphere is viewed through the glass from an opposite. I'm viewing it from the opposite side. If the diameter of the sphere is 20 centimeter, you know radius will be, okay, so radius of curvature will be 10 centimeter. Correct? Find the position of the image. If the diameter of the sphere is 20, find the position of the image. Refractive index of the glass as usual is 1.5. If you don't consider the mark to be on the diameter, you can't do this. Okay, this is your principal axis. Okay, whatever that is, line. Okay, this is your object. You're going to view it from the opposite side. You know the ray from here. So which is the pole? This is the pole. Why this is the pole? Because your ray from the object, I'm doing it in purple color. Because your ray from the object is going and striking that surface only. Here the incident ray was striking the first surface, so this could be called as pole. In that, the ray of light is going and striking it from here. It's going and striking this. If I'm going to look from here, it's going to be the incident ray. So this is going to be my pole. Okay, you know, from this is the point of incidence. You have to join it with the center of curvature. Yeah, and you know the light is entering from denser into rarer. It's going to bend away from the normal. So you know for the fact it's going to get bent away from the normal. So this ray would have gone like this otherwise, correct? It's going to bend away from the normal means it's going to go like this, yeah, slightly, so that I can draw something like this. If I bend it too much, I'll get into trouble. So then therefore this is your object, this is your image. Don't bend it too much, bend it slightly so that your image can be on the other side. This drawing becomes very, very critical. This is your center of curvature. And this is your eye. You've marked everything so beautifully. So you know that what is your object distance? Object distance here happens to be at the diameter itself. From the pole it's at the diameter. So u itself is minus 20 to the left side of the pole. It is to the left side of the pole. U itself is minus 20. R is also negative because the center of curvature is to the left of the pole. It is to the left of the pole. So R is also minus 10. Correct? And here the object, okay. Here the light is coming and falling and you're getting on the, okay. Which one should I compare it with? This, with which formula should I compare? I think I would compare it with I can't compare it with this because this is where the denser medium is. Okay. Yeah, the light ray is actually entering in the denser medium only. Okay, so denser to? Okay, once again, mu1 by v. Okay, which is the second one. Which, remember we learned this where object was in the denser medium. This is similar to object being in the denser medium. So since the object is in the denser medium, you have to take the second one. What is the second formula? It's mu2 by u minus mu1 by v is equal to mu2 minus mu1 by r. Okay, so do you know everything? You know the refractive index is 1.5. You know the object distance is minus 20. Correct? Minus mu1 which is 1, which is rarer medium, by v is what you're going to find out. So mu2 minus mu1 is 0.5 by r is minus 10. Why? No. Unknown values, you can't substitute sign convention. When you're substituting a number only, you should substitute sign convention. You can't write v as minus v and all now. You will get a negative answer which shows that v has got to be to the left side. Never substitute sign convention for alphabets. Okay. Only for the given. When you're substituting a numerical value, you should put sign convention. Are you clear? So then it's 15 by minus 200. This comes that side, it will be plus 5 by 100 is equal to 1 by v. Correct? Yes. So then this will be 200. So into 2. So it's minus 15 plus 10, which is minus 5 by 200 is 1 by v. So 5 4s are 20. So you have to get minus 40 to show that it's going to be on the other side. Okay, are you clear? Yes. Okay, so that's what it is. So minus 40 centimeter. Let's go to next question. So if you don't place the mark exactly along the diameter, you cannot even do the sum ever. So you should know this. Okay, so example 41. A small air bubble, okay, again along the diameter only you should assume. Your object is not along the diameter, you cannot even proceed. Okay, so a small air bubble in a glass sphere of radius 2 centimeter. Radius itself is given 2 centimeter. Appears to be 1 centimeter from the surface. Okay, so there is an air bubble somewhere. You know this is the center of curvature and this is the radius. Somewhere in you have an object which is the bubble. Bubble is the object. But you are getting to, it appears to be 1 centimeter from the surface means this is where your image is. You don't even know where your object is. You don't know. It will be somewhere along the diameter. That's all I know. So since they have said it's 1 centimeter from surface when looked at along the diameter. So I'm going to look at along the diameter. Okay, fine. Which means I can look at along the diameter. This is also diameter. I can also look at it from this end. Correct? So I'm going to look at an object along the diameter, and my image is here, which means I don't know where my object is. Okay, you know the radius itself is 2. This radius itself is 2 centimeter. The refractive index of the glass is 1.5. Find the true position of the air bubble, which is the true position of the object. Okay, so all you know is, you know the radius, you know the refractive index, you know the radius is 2. And which one can I compare this with? The object again is in the denser medium. The object again is inside only, which is second case, which is mu2 by u minus mu1 by v is equal to mu2 minus mu1 by r. Okay, which is the pole? This will be the pole again. To decide where the pole is, this is the pole. So, so this is the pole. Its mu2 is 1.5 by u, which is object distance. I don't know. I can't substitute minus u and all. Okay, minus mu1, which is 1 by what is v? From the pole, the distance is 1 centimeter. Correct? So can I take it as 1? Minus 1. Because v happens to be minus 1 because left side, so minus 1 is equal to mu2 minus mu1, which is 0.5 by r is again to the left side, which is minus 2, left side of the pole, so negative. So then I want to find 1 by v, 1 by 5 plus 1 is equal to 0.5 by 2 with a negative sign. So I can take this to the other side. 1.5 by u is equal to, let's multiply this with 10, so it becomes 5 by 20 with a negative sign, minus 1. So 1 by 5 by u is equal to 20 is LCM, minus 5 minus 20. 1.5 by u is equal to minus 25 by 20, which is 5 5s are 25, 5 4s are 20. 1.5 by u is equal to minus 5 by 4. You know 5 3s are 15 with a 0.3, correct? So then cross multiplying, u will become equal to minus 1.2 centimeter. U is to be, just now you know it's 1.2, which will be from the pole. So it's 1.2 from the pole, centimeter from the pole. So distance between the object and image happens to be 0.2 centimeter. So this is where your object is. So the light ray would have gone like this. Incident ray would have gone like this. Since it's entering from denser to rarer, it's going to bend away from their normal. So it's going to go like this, and then you would have had your image somewhere here. Okay, that's the completion of diagram, which you can do only after doing the sum, not before. Okay, well, Aurora would have drawn the sum directly. How the hell can you do that? Okay, so you can't. So can I go to next question? So next question is, there is a sample paper question which I'll try to do. It's example 43. Next is some on the example 43. Okay, a sunshine recorder globe, some recorder globe made up of glass of refractive index 1.5 has a diameter 30 centimeter, which shows the radius is 15 centimeter. Is made up of refractive index 1.5. A ray enters. Okay, draw the principal axis. A ray is entering parallel to the principal axis, shows that the object is at infinity. Now this is not, don't misunderstand this for a lens maker. In a lens maker, you are taking this refracting surface and this refracting surface and combining and forming a lens. Here you are not forming any lens, it is still a sphere only. So you should take this refracting surface. This is a convex spherical refracting surface in which object is entering from rarer to denser. You know, the normal has to be, this is the point of incidence. You have to join it with the center of curvature so that you get your normal. And the light ray will obviously bend towards the normal. This light ray would bend and normally go to this point I dash, which will serve as an object for the second lens, for the second spherical surface, which will further converge it, because you will have, it will further get an image, a final image here, because this is going to be again your normal. Let me do it in blue color with the center of curvature. Yeah. So this is the diagram. So you understand that first one, you have to consider this. Let me do it in purple color. The purple color acts as a pole. And let's talk only about this part initially. For this part, you know that the light ray is entering from rarer to denser, which is the first case. Rarer to denser is mu2 by v. minus mu1 by u is equal to mu2 minus mu1 by r, where mu2 is 1.5, by v you don't know, where that v is this whole v. This whole v is the first phase order v. Minus mu1 is 1 by u is infinity, because object distance is infinity, is mu2 minus mu1 by r itself is 15. For the purple color's phase, the radius of curvature will be to the right, so I can take it as positive, so then therefore it's plus 15. Correct? So then it's let's cancel this. 1.5 by v minus 0 is equal to 5 by 150. 5 3s are 15. So v therefore is 45 centimeter. Plus 45 centimeter shows that this v is 45 centimeter. Correct? Now, you know that is 45. Okay, which is going to serve as an object for the second surface, spherical surface. This whole thing is 45. You know the diameter itself is 30. So the 45 minus 30 will be 45 minus 30, 15 will be the object distance for the second phase. Object distance for the green color's phase, that will be the object distance. That's going to serve as an object for the second phase, right? So this is going to be 45 minus 30, which will be 15 centimeter. This is going to become the new pole, and 15 centimeter is the object distance. You know u is equal to plus 15 centimeter. The radius of curvature, you know, still 15, but it's minus 15 because for the green phase it is to the left, so minus 15. And here the light ray is entering from denser to rarer. When it's denser to rarer, you're going to write mu2 by u minus mu1 by v is equal to mu2 minus mu1 by r. Okay, mu2 itself is as usual 1.5 by u itself is plus 15 minus mu1 is 1 by v you don't know, which is equal to 0.5 by r itself has got to be negative, which is minus 15. So then therefore take it to that side. This is 1, what did I write here? Mu2 is 1.5. 1.5 by 15 plus 0.5 by 15 is equal to 1 by v. Let's multiply the numerator and denominator by 10 plus 5 by 150. It's 15 tens are. This is 5 3s are 15, correct? So LCM will be 30. 3 plus 1, 4. Yeah? So this will be 2 by 15. So V is equal to 7.5. So it's positive, and 7.5 shows that this distance is 7.5 centimeter. And that's where it's going to cross the axis. Very beautiful sum. It's only in the sample paper in the year 1998. It's a very old paper, but still you get to understand how to do these kind of sums. Okay. Now we have dealt so far with the sums which were spherical refracting surface. Now we don't know, we have never dealt with a lens maker. So I'm going to teach you sums, and so you will be able to understand the difference between that sum and this sum. Okay, let's do this sum, which is example 44. The radius of curvature, I'm recording, no?
Yes, ma'am.
The radius of curvature, okay. The radius of curvature of each phase of a biconcave, in the biconcave lens. Abdina lens makers. Biconcave. Biconcave lens na idha. In the lens onu sethu biconcave lens purida. Biconvex idu. Biconcave means, okay, let's see. Radius of curvature of each face of a biconcave lens made of refractive index is 1.5 centimeter. The radius of curvature itself is 30 centimeter. Find the focal length. Refractive index kudutale 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2 ன்னு தெரியும் lens makers. இதில் பார்த்தோன்னே எனக்கு lens makers ஐடென்டிஃபை பண்ண முடிஞ்சிச்சு, கரெக்டா? பட் இது வந்து he is given biconcave. ஓகே, biconcave பொறுத்த வரைக்கும் supposing it's like this ன்னு வச்சுக்கோ. You know that the first one ஓட radius is negative, the second one ஓட radius is positive. Okay, this is to the left of it, this is to the right. So r1 is negative, r2 is positive, and biconcave shows that both the radius are the same. It's not r1 r2, it's r and r. So in the இடத்துல you can substitute not r, you have to write minus 1 by r. Minus 1 by r. Because this r1 is negative and this r2 is r, which is positive. So this negative stays as it is. 1 by f is equal to mu minus 1, which is 1.5 minus 1. So 1 by f is equal to 0.5 into minus 2 by r, correct? R itself is 0.5 into minus 2 by r itself has been given to be 30. Just substitute that here. So 2 1, this will become 15. And this is 1 by f, right? Okay, you need not have cancelled that. Instead you could have written 0.5 into 2 itself is 1 minus 1 by 30, correct? Is 1 by f. So f itself is minus 30. So the biconcave lens has a combined focal length minus 30. Obviously biconcave lens. So you should understand the biconcave means it's like this. This radius is negative, this radius is positive. The R1 is equal to minus R. R2 is equal to plus R, so that you can substitute it in lens makers. Are you clear? So let's go to example 45. Okay, in the identification of what is the question, especially that question which will come for exam. Two beam of light converges at a point 30 centimeter. Means this is the pole, this distance is 30. And this is going to converge it at some point. So then which is going to serve as an object for the second lens and all that. Something like that I did. I don't remember that, but okay, so just make sure you're thorough with those kind of sums. Will be very important. Okay, I can't recall it though. Example 45. The radius of curvature of a double convex lens. This radius is R1, which is positive, is equal to R. This radius is R2, which is minus R. And 1 by f is equal to mu minus 1 into 1 by R1 minus 1 by R2. What are they given? They've given that the radius of curvature of the double convex lens are, it's not the same. R1 and R2 are not the same. They've given it as 10 centimeter to be R1 and R2 to be 15 centimeter. R1 is always this, which is 10 centimeter, which is positive. R2 is this curvature's radius, which is negative, which is minus 15 centimeter. Are you clear how to identify R1 and R2? So then they have given the refractive index to be 1.5. The focal length itself is 12. Find the refractive index. Mu is the question. 1 by R1 is 10 minus 1 by R2 is minus 15. So it's 1 by 12 is equal to mu minus 1 into 1 by 10 plus 1 by 15. So 1 by 12 is mu minus 1 into, this will be 30, right? So 10 3s are and 15 2s are, 3 plus 2 is 5. This and this will get cancelled as 6. So this 6 and this will get cancelled. A mu minus 1 is equal to 1 by 2. A mu is equal to 1 by 2 plus 1. Mu is equal to 3 by 2, which is 1.5. Do you understand? Okay, இது மாதிரி சம்ஸ் கேட்டிருப்பாங்க, நீ எக்ஸாமில் பண்ணாமல் வந்திருப்ப. யோசி, ஏன்னா உனக்கு அது என்ன, அது வந்து லென்ஸ் மேக்கர்ஸா இல்லை இது ஸ்பெரிக்கல், அந்த ஐடென்டிஃபிகேஷனே தெரியாமல் இருந்திருக்கும். புரியுதா? நீ கரெக்டாக நான் சொல்கிறது. சரி, இது முடிச்சப்புறம் என்ன பண்ணணும், உன்னோட கொஷின் பேப்பரில் இருக்கிற அந்த பர்டிகுலர் சம்ஸ் எடுத்து பார்க்கணும். when you go back home, see if you are able to perform in that paper. Okay, so next is example 46. Example 46. A biconvex lens. The word itself shows that it is lens makers. A biconvex lens has a focal length 2 by 3rd of radius. Focal length is 2 by 3 of radius of curvature of either surface, which means both of them are having the radius r only. And f is equal to 2 by 3 of r. Calculate the refractive index. 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. You know this is positive r, this is negative r. This is your r1, this is your r2, correct? So then 1 by f itself is 2 by 3 of r is equal to mu minus 1 into 1 by r1 is positive r, r2 is negative r, so plus 1 by r. So it's 1 by 2 by 3 r is equal to mu minus 1 into 2 by r. R and r directly gets cancelled. This goes, that's it, will become 3 by 2 is equal to mu minus 1 into 2. The 2 can come this side as 4. A mu minus 1 is equal to 3 by 4. Mu is equal to 3 by 4 plus 1. Mu is equal to 4 is LCM, 7 by 4. Which is 1.75 is the answer, correct. So that's all. Refractive index doesn't have any unit. Are you clear? Yes. Okay, next, like this, there are many questions that we can do. I'll just do selectively. Okay, example 48. Okay, the radius of curvature of a convex surface of a plano-convex lens. Plano-convex. A plano-convex lens. Which means this will be infinity for the radius of curvature of this. The only this will have, this R1 itself is infinity. R2 will be minus R, whatever the radius they are going to give, correct? So I've drawn a plano-convex lens whose focal length itself is 0.3 meter. The refractive index of the material itself 1.5. Find the radius of the convex surface. 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. R2 is in this side. Okay, but let's first write 1 by 0.3 is equal to 1.5 minus 1 into 1 by infinity minus of, I'm going to find R. Okay, so I think I can, if I'm going to, should I write a minus R? Because already negative. But instead of R2, I'm substituting minus R. So I can write minus R. Okay, I'm assuming that I'm correct. Let's see. So 1 by 0.3 is equal to 0.5 into 1 by infinity 0 plus 1 by R. And the thing is, when you find the radius, it's got to be positive, right? It's got to be negative. It's got to be negative, right? So then, which means you should write it as plus R so that it still remains to be minus R, so that your answer can be negative. You understand? So no need to put the sign convention. Let's keep it like that. So then, therefore, what should I write? This goes this side, become 1 by 0.3 into 0.5 is 5 3 so 15. 0.15 is equal to 1 by R with a negative sign. So R itself is minus 0.15, which shows that it's to the left. But they have not done it though. They have changed it to plus and they found R. But you know that the radius of curvature with the sign convention has to be negative. It doesn't matter. You can say the magnitude of the radius of curvature is 0.15. It is to the left. You can say like that. So next, let's go to next question, which is the example 49. Okay, a convex lens of focal length. A convex lens, okay, a focal length 0.2 meter and made of glass is immersed in water. Okay, the refractive index of glass is 1.5, refractive index of water is 1.33. Find the change in the focal length of the lens. Okay, a convex lens is made of glass, is immersed in water. First we are doing the experiment in air, then completely immersing it in water. Find the change in the focal length. Okay, so when you're keeping it in air, there's one focal length. When you're immersing it in water, there will be completely another focal length. Okay. See, இந்த சம்ம பொறுத்த வரைக்கும் வெறும் கான்வெக்ஸ் லென்ஸ் தான் கொடுத்துருக்கான். ஸோ கான்வெக்ஸ் லென்ஸ்னு கொடுத்துருக்கான், பட் இஸ் இமர்ஸ்ட் ஃபர்ஸ்ட் இன் டூயிங் இந்த எக்ஸ்பெரிமெண்ட் இன் ஏர், நெக்ஸ்ட் டூயிங் த எக்ஸ்பெரிமெண்ட் இன் வாட்டர் அப்படின்னு கொடுக்குறான். அந்த மாதிரி கொடுத்தாலே அந்த ஃபோக்கல் லென்த் அவன் கேட்குறது வந்து ஃபைண்ட் த சேஞ்ச் இன் த ஃபோக்கல் லென்த். அப்போ நீ ஃபோக்கல் லென்த் மாறுது பேஸ்ட் ஆன் த ரிஃப்ராக்டிவ் இண்டெக்ஸ்னா the only formula you can use is 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. ஏன்னா இதில் தான் கிளாஸ் வித் ரெஸ்பெக்ட் டு ஏர்னு ஒரு ஃபார்முலா இருக்குது. இதில் தான் 1 by f is equal to mu of கிளாஸ் வித் ரெஸ்பெக்ட் டு வாட்டர் minus 1 into 1 by r1 minus 1 by r2ன்ற ஃபார்முலா இதில் தான் வரும். இப்போ இதை வச்சு நான் போடும்போது ரிஃப்ராக்டிவ் இண்டெக்ஸ் பேஸ் பண்ணி எனக்கு ஃபோக்கல் லென்த் வில் வேரிங்கிறது எனக்கு இதில் கிடைக்குது. வேறு எப்படி பண்ணாலும் எனக்கு அது கிடைக்காது. ஸோ ஐ ஹேவ் டு நெசசரிலி யூஸ் திஸ் ஃபார்முலா ஒன்லி. ஓகே, இங்கே பொறுத்த வரைக்கும் யூனோ 1 by f வாட் இஸ் சேஞ்ச் த ஃபோக்கல் லென்த்னு கேட்குறானா. ஓகே, கான்வெக்ஸ் லென்ஸ் ஃபோக்கல் லென்த் ஃபஸ்ட்டு கொடுத்துறான். இதுவே 0.2 இஸ் immersed in water. ஸோ இதோட ஃபோக்கல் லென்த் வந்து இன் ஏர் which is 0.2, which is equal to glass one, the refractive index is 1.5 minus 1 is 0.5 into 1 by r1 minus 1 by r2. இது வந்து எனக்கு r1 r2 வந்து சேம் ரேடியஸ்னு கொடுக்கல, பைகான்வெக்ஸ் லென்ஸ்னு கொடுத்தா தான் ஐ கேன் டேக் r and r to be the same. இங்கே சேம் ரேடியஸானு கொடுக்கல, அப்படியே மொட்டையாக விட்டுட்டான். ஸோ நான் அதனால இந்த 1 by r1 minus 1 by r2 கண்டுபிடிச்சிக்கலாம், which will be 1 by 0.2 into 0.5 will be 5 2s are 10, which is 0.10 அப்படின்னு எனக்கு ஒரு ஈக்குவேஷன் மட்டும் தான் கிடைக்கிது. கரெக்டா? விச் இஸ் நத்திங் பட் இஃப் ஐ மல்டிப்ளை அண்ட் டிவைட் பை 100 it will become 100 by 1, which is just 100னு கிடைக்கும். ஸோ திஸ் will just become 100. ஸோ ஐ got one equation using air. Now coming back to this, you have to find the focal length when this itself mu of glass with respect to water, which is nothing but mu of glass by mu of water. Both of them with respect to air. Mu of glass with respect to air is 1.5. Mu of water with respect to air is 1.33. So in this place I should substitute only that, which is 1.5 by 1.33. So 1 by f is equal to 1.5 by 1.33 minus 1 into 1 by r1 minus 1 by r2, correct? Which is 1 by r1 minus 1 by r2 according to first equation is directly 100. So with this I can find 1 by, excellent சொல்கிறேன். So 1 by f is equal to, இது LCM வந்து 1.33 na 1.50 minus 1.33 will be 7, this will be 4, this will be 0.17 into 100. So this is 1 by f na, இது வந்து first multiply பண்ணிக்கலாம். 17 by 1.33 which will be 1700 by 133 is 1 by f na, f therefore is 133 by 1700. Correct? 133 by 1700 இருக்கணுமே. Calculation mistake தான் பண்ணிருக்கேன். So far, can you see? Into 100 will be 17 by 1.33. 1700 by 133. Correct தானே இருக்கு. .17 by 1.33 into 10 ன்னு போட்டிருக்கான். இங்க 10 ன்னு போட்டிருக்கான். Did I get it as 5 2s are, what is it? 0.5 into 0.2. 0.5 into 0.2 is 10, 0.10. So 1 by 0.10 is like multiplying by 100. Multiplying by 10, it will become, multiplying by 100, it will become 10. So it will become 10 only, no? Sorry, I made a mistake here. So it's 10. I made a mistake here. It's just 10. Hope we can correct it. Okay, guys, I'm sorry. So then therefore it will become 1.7 by 1.33 or 170 by 1, correct? It will be 170 by 133. So the reciprocal of it is 133 by 170. So the answer for this itself is 0.78. This is the focal length when immersed in water. So for the same length, the focal length is changing. Do you notice that? The focal length in air was given to be 0.2. The focal length in water is now found to be 0.78, which means the focal length has increased when you're immersing in water. This is the moral of the story. You should know it offhand. In the air, the refractive index will be lesser, but the moment you immerse in water, the focal length is lesser. The moment you immerse in water, the focal length is becoming larger. Do you agree with me? Yeah. And the difference in focal length is 0.78 minus 0.20, which is 0.58, which anybody can do. But let's understand this. Air la irukumbodhu focal length is small. Water la nodichona focal length is more. Why is that? அப்படினு சும்மா layman மாதிரி யோசிச்சு பார்க்கலாமா? Okay, இப்படி பண்ணினா இப்படி கிடைக்குது. That's the conclusion which you're supposed to remember it. Okay, let's see. Let me think about it. Okay, airல ஒரு lens இருக்கு. அதே waterல இருக்கு. இது வந்து it's entering from air into glass. Air to glass போது normally parallel beam of light come to a focus at the principal focus, correct? Air to glass போது இங்க வந்து water to glass. Water is ஏற்கனவே denser medium. ஏற்கனவே denser to rarer வந்து air to glass வரும்போது ரொம்ப பெண்டிங் இருக்கும். ஆனால் வாட்டர் டு கிளாஸ் வரும்போது ஏற்கனவே வேரியேஷன் இஸ் லெஸ். ஸோ கொஞ்சம் தான் பெண்டிங் இருக்கும். கொஞ்சம் தான் பெண்டிங் இருக்கும்போது ஃபோக்கல் லென்த் இஸ் மோர். வேறஸ் ஹியர் மோர் பெண்டிங் ஃபோக்கல் லென்த் இஸ் லெஸ். அப்படிங்கிறது ஜென்ரல் காமன் சென்ஸை வச்சு நம்ம சொல்கிற விஷயம். அதை இந்த சம்மில் அரைவாரோம். ஸோ கேன் ஐ கோ டு நெக்ஸ்ட் சம்? I think this is enough. Okay, I think whatever I've done is enough. This kind of sums you'll be able to manage. I've covered most of the sums which are important, and then is about magnification. I'm stopping this video. This completes everything here.